Good day, STEM students. In today's video, we shall be discussing about projectile launch at an angle. Please get your pen, paper, and calculator. We shall begin in 5, 4, 3, 2, 1. Projectile launch at an angle. So we have here a ball which is moving in projectile. Notice that in the first position we have here a vertical component. Same here and the same here. But notice that in this point, at this point where it is at its highest point, notice that the vertical component is missing. This is because when an object reaches its highest point, it suddenly stops, and then notice it moves down. Notice the red arrow which is pointing downwards. That is your velocity moving down, or your vertical velocity. Sample problem: an object is launched at a velocity of 20 meters per second in a direction making an angle of 25 degrees upward with the horizontal. Question: what is the maximum height reached by the object? What is the total flight time of the object? What is the horizontal range of the object? Okay, in solving this problem, we should first write down the given, which are the initial velocity, which is 20 meters per second, 25 degrees, which is the angle. And though it is not written on the problem, we always have an acceleration due to gravity, which is negative 9.8 meters per second squared. Now we are asked to find for the maximum height, the time in flight, and then the range. Now to solve this, let us first consider the first question, which is the maximum height. So here is the sample object, and it has a velocity of 20 meters per second and launch at an angle of 25 degrees. Now in solving this, we must decompose it. It means we should separate its vertical and horizontal component as shown here. So here is your vertical component, and then here is your horizontal component, and here is your angle. So in this case, again, we should find the horizontal and vertical component of the velocity. So notice here we have a triangle formed. So when we solve for each component, we use the trigonometric function. So first we have the horizontal. So if this is the horizontal and this is the hypotenuse, what trigonometric function are we going to use? Is it SO? Is it Ka? Or is it TOA? So since this is an adjacent and this is the hypotenuse, we shall be using Ka. C, which stands for cosine. So cosine 25 degrees is equal to its horizontal, or its adjacent, over hypotenuse. So VIX over V. Now we cross multiply the given. So we have V, the velocity, times cosine 25 is equal to initial velocity of the horizontal. Substituting the value, we have 20 cosine 25. Using your calculator, you will have an answer of 18.13 meters per second. Next, to solve for the vertical component, Again, we use a trigonometric function. Since this is the opposite and this is the hypotenuse, we shall now use saw, which is sine opposite over hypotenuse. So here we have sine 25 degrees equals vertical over the velocity. Now cross multiplying, we have velocity sine 25 equals the vertical. Now substituting the value, we have 20 sine 25. We'll arrive at the answer of 8.45 meter per second. Next, we go to the problem. So again, here is the ball which is moving in a projectile motion. Now this circle is its highest point. So since we are asked to solve for the vertical component, we should concentrate on the vertical axis or the y-axis. So we have solved this 8.45 meter per second, and we have an acceleration which is negative 9.8 meter per second squared, and we are asked to solve for the dy or the y or the height, which is this one. So the final velocity is equal to initial plus acceleration plus times time. Second equation, we look at y, or sometimes we use this as distance equals the initial velocity plus 1/2 AT squared. And last, we have here the final velocity squared equals the initial velocity squared plus 2 times acceleration and y or dy. Now, looking at this formula, can we use the first equation? Okay, definitely not, because there is no given distance. So we cross this out. Next, for the second equation, although we have a given of y or dy, time is not yet given at this point. So we will cross this out. Here we have the final velocity, we have initial velocity, and then acceleration and y. Notice we have a given of acceleration and we have a given of initial velocity y. Now, do we have a final velocity? Now, let us recall that when the ball is at its highest position, the final velocity is 0 because it temporarily stops and then it moves down. So at the highest point again, the final velocity will be 0. Okay, and then we substitute other givens. So we have 8.45 meter per second, and then to be squared plus 2, and then the given acceleration. So transposing this to the other side, so it becomes negative 8.45 meter per second squared, and then divide both sides by 2 times negative 9.8 meter per second squared. So you will arrive at an answer of 3.645 meters. So this is the maximum height of the projectile. Okay, so moving on. So next, we are asked to solve for the total time. So when we say total time, the time in flight until it hits the floor. Okay, so here we have the formula Vfy is equal to Viy plus At. Now again, assuming that this is the highest point, we can solve for the time at this point, but we are not yet done solving for the total time. Okay, so we'll just first, we'll do it one at a time. So again, our final velocity in this case is 0 because it stops at its highest point. And then we substitute the given value, which is 8.45 meter per second, and then the acceleration. So same procedure, we transpose 8.45 to the other side, and then divide both sides by negative 9.8 meter per second squared. So the answer would be 0.862 seconds. But we are not yet done. Now to solve for the total time, so it is understood that the time going up is equivalent to the time going down. So what we'll do to solve for the total time is we simply multiply it by 2. Okay, again, the time going up is equivalent to the time going down. That is why we multiply this by 2. So the final answer would be 1.724 seconds. Now let us now solve for the range. Now we have the given of 18.13 meter per second. Let's go back to the basic formula in finding the velocity. Recall that velocity is equal to distance over time. Now deriving the equation, we cross multiply. So we will have Vx multiplied by t equals to dx, which is the range. Now simply substitute the value, which is 18.13, and then your computed total time. Okay, you will arrive with an answer of 31.265 meter. So this is your answer, 31.265 meter. Hope that this video helped you in solving problems with regards to projectile launch at an angle. Good day, God bless, and Jesus loves you.